Hello, everybody. So, looks like we're into module 6 now. Gonna start this evening, continuing where we were the other day, looking at some more stuff about movement without the useful nav mesh thing, but really that nav mesh that we looked at first makes movement of our characters, the non-playable and mob characters, it makes it a whole lot there's a whole lot easier for them, even if our regular character is going to move. And most of our major game engines do have pathfinding options. We'll look at some more stuff about movement there. And last time we looked at it, we only saw the opponent character moving. So we'll take it one step further this evening because the basic logic follows suit. So that'll go together quickly, and we'll take it a step further and have the opponent characters attack our character, or at least see something along those lines. And then module 6 is where we get into some stuff about animations and sprite sheets. So my plan is after the break, we'll do that. And we still have a sound quiz to do at some point, which I think I'll probably go ahead and throw that in module 6. That way it's not an extra thing there when you're trying to finish up your project at the end. The sound quiz will be fairly straightforward. I have it ready. I just have to publish it. I just had to decide where to put it. But basically what it is it's going to be questions like find a good sound for a car wreck. And I'll give you something like that. It'll be like 5 of them. And if you just go to Google, there are lots of places where we can download free sound effects. That might be a good thing to start with, download free sound effects. Mixkit, free sound, I've used them a few times. They have a lot of stuff on there. But there's lots and lots and lots of sounds of these. Some sound of a river, a trumpet, a bunch of random sounds, frogs chirping, background noises, and search for things. So like that one I just mentioned, we can search for sound of a car wreck, explosions, riverside villages. I don't think my sound's shared right now, but let me stop screen share so I can share with sound. There you go. And I'll give you just a second. You might want to adjust your volume between my voice on the microphone and an actual explosion sound that I'm getting ready to click on. Okay, I'm gonna go ahead and click on this now. So find sounds like that, something that sounds like a car wreck. Oh, that's 30 minutes long. That's not really a sound effect. And I'll just throw out for that quiz. It's not really a quiz. It's labeled as a quiz because of the way Ivy Learn and Canvas products put things together. But it's just an assignment. There'll be some scenarios and go find sound effects that would work for it. So like car wreck sound effect. You can just search right for it and practice some on that. There's a bunch on there. Download 50+ car crash sound effects. So there's no shortage of them on the internet. So it'll be labeled as a quiz, but just because of how Canvas products force that label on things when we build the assignment right there in Canvas, instead of having something external that we upload, which Canvas forces us to label as assignments. So I'll probably go ahead and release that one, but that'll be easy. It's just 5 scenarios where you just I guess if you want to approach it like a quiz, prove that you have the ability to go find a good sound effect. I know there's a couple musicians amongst this group, so if you to do audio stuff yourself, if you want to make some sound effects and do your own thing, that would be fine too. For crushing an aluminum can along with some mixture of bottles can replicate that one I just noted, right? Crushing aluminum cans and breaking glass bottles is going to sound exactly like sound an awful lot like a car crash. If you want to make your own, that will be fine as well. But all you'll have to do is just go find a good sound effect for that, and that's really just a Google search, or since it's a common game asset, there's some in the Unity asset store if you want to just look there. There's also some stuff with 3D animations, and we'll get to that this evening. One note I had on here, the latest version of Unity, I guess they're phasing out the old UI elements, the text and drop down, and the ones that we looked at earlier, in favor of the Text Mesh Pro. They have very similar behavior. It's mostly an appearance thing, but there is some access issues. For example, the Text Mesh Pro output text doesn't have a .text attribute we can grab. And the instructions in our book for the games were written with the old style one, which they're phasing out, but it's not gone yet. So depending on when you installed Unity, it might have moved on the menus. On mine, I see both of them, but on some of them, that menu also has another sub menu called Legacy, and you can find the old text stuff there. You can find the old ones there under the Legacy menu. Those will match the instructions. Otherwise, you might need to look up some things like what the variables are named differently. Like if you want to grab the text from the actual text written in the text object on the Text Mesh Pro one, I think that is .value. I'd have to look it up. I haven't used those very, very often, but if you want to use the Text Mesh Pro ones, you might just need to look up and see what that particular value was renamed to in some cases, or go to the Legacy menu, and then that's the old ones, which will match the instructions in the textbook. Make that note. So now continuing where we were the other day, before we get into that, does anybody have any questions? Okay, I assume the silence means no questions. I don't know why I didn't open this beforehand. That kind of wastes a lot of time. So the other day we were looking at the manual movement of the character, or normal WASD controls, or a plug and play joystick, since we set it up with the input manager, and started kind of hinting at some of the physics terminology we will take a look at. I'm thinking next Wednesday is my current plan for that, and quickly go over some of the physics. So we set this one up. I guess that didn't take too long. Goes down. Okay, so there's that save thing. Our saved game file got deleted. It throws up an error, but our game still works exactly the same. Well, maybe it doesn't. Might have to deal with that being deleted first. Oh. I don't know why Unity isn't able to open my text editor. It does fine. It opens it on the Mac, but so a quick way to deal with this is maybe throw that in a try catch block. Move on. And not being able to load the save game isn't really a problem, because like we saw there, if there's not a save game, we'll just go ahead and do other stuff. We do have to have exception. And for some reason, they recently changed our script template in Unity. And our exception handling will throw an error with the latest change to the script template. All of the exceptions are in just the system library, the regular C# system library. So we do need to import that if we're going to use try catch blocks. So I'll just do that. Try and load the game. If there's not a game, then just move on. I'm just going to, it's not really a problem. So otherwise, I don't know what those other messages were for. Oh, well, that's a problem. Let me see if this works. Nope, it's going to make me put a catch there. I don't think I can do this in Unity. All right, I don't think I can do this in C#. Oh, it looks like it let me. So apparently, just importing system conflicts with Unity's random number. That's probably why they removed it. That would make sense. And that's where our exception handling is. So I'm just going to avoid catching a particular exception and just do a catch all thing, but it's not doing anything. It's just required for that part of the syntax. And because everybody's seen exception handling before, the try catch blocks, sort of a glorified selection structure. So try to do this. If that doesn't work, then do this stuff, which we don't need to do anything. That's where we actually fix stuff. Textbooks and tutorials always fall short because it's a very textbooks and tutorials usually just go with print out a message, but that's what happens when we don't handle the error. So really what we should be doing there is a whole bunch of instructions to actually fix the problem, not just print out a message, because printing out a message is what happens if we don't address the problem. But it's time consuming. So, and time consuming and very specific to the situation. So it doesn't fit well in classrooms and tutorials. And there we go. So we used an acceleration. So when we push our key, there's a value. And until we get up to the full speed of the character, it just accelerates up. It's going to accelerate in that particular direction. So the stuff we were looking at the other day, and what we did is an acceleration, and we just did a generic check that when our velocity passed a certain, got up to a certain amount in some direction or another. Ideally, when not constrained for time, this sort of check would get a little bit longer and a little bit more detailed to make sure you want to move. But well, we have positions. Again, preview for the physics stuff coming up. We're worried about position and we want to change the position. And changing position is a velocity, which if we're not pressing the keys, our character is not moving, our velocity is 0. So we have to change velocity in order to change position. So we came up with a new vector, an acceleration in some direction or another. And that acceleration changes our velocity, which then is a change in our position. So using the normal physics terminology to move our character. And we just set an upper limit so that if we're already going at the top speed, then don't accelerate anymore, which could be a lot more refined than just throwing a 2 in there. That was sort of a cut down for our example. And then we did this hit point thing, so we'd have something to save. But we can kind of duplicate this sort of movement for our other characters in the game. So I'm going to add a couple another character. Let's see. I'll just do an object. I'll bypass the other stuff for now and put a cube. So our cylinder's main opponent will be a I guess red cube. That seems the opposite of a blue cylinder. I'm going to do this in a couple steps though, because normally, along with our opponent, I'll rename that different. Along with, we have 2 other types of characters moving. I'll add in a sphere for NPC. We're going to have the mobs and the NPCs moving. So we'll need to kind of, they'll basically move in the same direction, but the biggest difference is what happens when they interact with our character. So I think for our example here, I was thinking we could just have the NPCs walk around like background characters, but the mob will actually have that attack our character. I'm just going to add some colors in real quick, create a new material so that we can add colors to things. Get red maybe. There we go. And there's one more. Create a material. The NPCs and oops. Bring this over here first and then change the color on it. Yellow. That'll work. So they're both going to move. I'll just leave the NPCs as background things walking around, kind of harmless. But the mobs will generally move in the same direction, except we will eventually want them to attack our character. So once again, it's best if we use the laws of physics to move stuff. That way we get a more realistic looking movement. So I'll put a rigid body on it so we can access that rigid body to get the movement. Where'd that go in at? Oh, up there. Probably not going to hurt if the sphere rotates. Don't need to apply gravity. The defaults are good there. The cube, we would definitely notice the cube rotating. So probably don't need the cube rotating and bouncing all over the place. And when you're really getting into it and spending a lot of time trying to replicate physics, it's a good idea to apply things like mass and air resistance or water resistance, things like that, because there is a really nice physics engine that can duplicate all that. So now if we hit run, we should at least see everything on the ground. Okay, yeah, it looks like gravity applies. If I move this direction, it's capable of bumping into it. So we do get collisions happening and stuff, so we should be able to detect that. So I'll make a new script, create a C# script called character that can handle the basic movement for both of them. Which is going to be very similar to our player movement. Enough so that I'm going to start by copying the player movement. Well, first thing I'm going to do is label the closing curly brace so don't get lost in there anywhere. Let's see. So we'll need a rigid body and a speed. Maybe top speed might be a better term for that. Paste those in. The start method. I don't think in our case, I don't think we need to load the game here, so I'll get rid of that. The update method will be pretty much identical. Oh, wait, no, it won't. Identical for the movement part. And then one more closing curly brace, because all we need to do is sort of consider the movement. But just like we saw the other day, the one or just like we saw last week, it's not the player that's going to be making those decisions. So we can get rid of that input access stuff and start by wandering around in random directions. There's not much here, so I'm going to kind of get this out of the way. Oh, I guess I could have collapsed that. We do have the ability to collapse our methods. That might have worked better for what I just did. But since it's only one line, I was like, oh, I'll just put it in one line. That keeps that part out of the way because all we're doing is grabbing the component. For this, we need to keep track of the direction we're going in. Which I'm going to do as an integer. So we'll keep an integer called direction. And just like before, it's good to have a time-based thing. And over the years, I have found it so much easier to just make my own frame-based counter than use human timing, because we have different mindsets there, right? As we're putting our game together, we're thinking about frame by frame by frame, not human scales. So it can be well, that's just what I've found over the years works better for me. I'm not changing my mindset and just building my own timer based off how many frames have passed, which is just one number that kind of goes forever. It's not going to be needed from outside an integer tracking the frames. And then every time we run a frame of the game, we'll just increment that counter. So then we can do certain things based off how many frames have passed, such as choose the direction. So maybe that's a good first thing. So if like frame mod, so for years, whoops, that's not mod. For years, the default in Unity was 140 frames per second. But on the latest installs, starting last fall, they went back to 60 frames per second. I'm not sure why they dropped it back down, but I'm sure they had a good reason for doing so. We can reset it, but whatever we set it at, mine's still set at 60 frames per second. So to go change direction every 4 seconds, maybe be around 240. So I'll just do mod 222 around 4 seconds. If that is equal to 0, so if our number is evenly divisible by 222, 240 would make it approximately 4 seconds. But after that many frames have passed, then we'll change direction. And I'll just put all that in one method to keep it organized. Because again, this is a stripped down example to refer to. So I thought methods will help organize that. So now we can just come somewhere else in our object and create that. Public void, we don't need to return anything. Yes, this is for the enemy and the NPCs. So we're going to start with just the movement, and then we'll have the enemy attack. So anything that's not player controlled. Change direction. And just like we saw before, in general, it's going to be a random direction. If there's not something specific to do, like the opponent doesn't need to attack our character. Last week, it was just chasing our character. This time, we're actually going to attack because our character has some hit points. We can just do a random number. So I'll make a integer called new direction is random number in the range of 0 to 8. And where I got those numbers, I'll write on the board. This is the 3D situation, but we're really doing 2D stuff, right? So we're walking around on our XZ axis. And we need to pick a direction. So if we add a couple more in there, we get our horizontal, our vertical, and a couple angles. And then we can just give each one a number. So 8 different directions, but you could easily expand that to get the other ones in between, get a little more refined control. But just a random direction, and 8 seemed like a good number to make our character randomly wander around and kind of see how to do this. And well, I make direction in it. Direction wasn't supposed to be an integer. I'll come back and change that in a second. Does anybody realize what direction was supposed to be? New direction's an integer because that's just 1 through 8. But then that's which direction we need to go in. But like in the picture, I didn't draw points. I didn't draw a single dot, right? So our actual direction needs to be a vector. And then we can just do a switch case would work. Switch on new direction. And what do we have? Case 0, case 1, case 2, case 3, case 4, case 5, case 6, case 7. So as I drew it on the board, 0 would be our positive X direction. So I'll make this X and Z. Since we're like looking down on that 3-dimensional plane, the way Unity labels them. So if we're going in in the positive X direction, well, Direction is, it needs to be a new vector 3, right? And that's what I messed up on earlier. Direction's not a, whoops, paste that there. Direction's not an integer, that's an entire vector. Yes, in the chat room it popped up, same thing for 2D, but with a vector 2 instead of 3D. And yeah, it's just that one less vector. It's actually the exact same thing, because our y, we're ignoring the y direction here, but our positive x direction would have our speed in the x value, no y, and then nothing in the z direction. And then we'll break, and they're all going to kind of look like that. So I'll just copy and paste that in everywhere. I don't know why that didn't indent though. For some reason, the text editor doesn't want to automatically indent that. Not that indenting is really a problem, but I believe I've stated it a couple times. Always copy and paste as much as possible, because computers never make typos. Humans are the ones that make typos. So if we're in the x direction, it's all x and no z. All of these are going to be no y values. Case 1, 2 is the positive z, so it'll be no x and all y. Get to that one in a second. 3, 4 would be negative x, so we want to go negative speed. 5, 6 is our negative z, so I'll cut that from there, paste it over here, and add in a negative sign. And then our other ones, we kind of split up between the two. So it'll be half of our speed in the x direction. So when we're going this way, half of our speed is the x direction and half in the y direction, and then those blend back together to give us that diagonal. So half in the x direction, half in the z direction. Then when we're over here, again, it's half and half. With number 3, as we go around kind of counterclockwise, like I labeled it on the board there, 3 is a negative x and positive z. So we just add that negative sign in, add a negative sign in somewhere. Case 5 is half x, half z, and 5 going down that way is going to be negative for both of them. We're going in the negative x direction and the negative z, just from the way I labeled them. Obviously, we could label these differently. Then 6 and half x, half z, and we have or 7. Yeah, on 7, we're going in the positive x direction and the negative z direction. So throw that negative sign in there. So that gets us several random directions that we can choose from. Every about 4 seconds or so. And well, this line and the curly brace that went with it, those had to do with the movements. Oh, oops. We have a direction. I'm going to increase this so it goes a little faster. 2 seemed kind of slow. And we want to change to go in that random direction. So hopefully that made sense. What's this curly brace close? That's the one I meant to delete a moment ago. Get rid of some white space so we can see stuff clearly. So if we do that, that'll be our first condition. Obviously, we're going to have more, a lot like what we saw before. And then if we're not already moving fast enough, which by the time we reach 4 seconds, we'd be moving plenty fast enough, then our did I miss something? This way, the chat room said scroll over, something seemed off. Oh, that should be a dot Z. And then the 3 is over here. Thank you. And if you have something to say, go ahead and unmute and speak up. One of my favorite phrases that I've heard in the last year is there's no such thing as an interruption in a Zoom call. I know since birth, we've all been trained that thing in the classrooms, just raise your hand and wait politely on your turn, but that doesn't work on a Zoom call. If you notice, especially if you notice a typo, feel free to unmute and speak up, but I keep an eye on the chat room as well. So we'll pick a random direction and then start moving in that direction. So barring any more typos, I think that got us there. Oh, whoops. Forgot the floating point things. Need F's all over the place here. Since we're in a video game running at many frames per second, it's really nice if we can save those 32 bits because, well, at 60 frames per second, 32 times 60 is what? 1800 plus 120. So 1920 bits that aren't being used from using floating point numbers over double precision numbers. So it adds up really quickly. And then we should be able to just attach that script to our 2 things that need to move. Bring that here and NPC. Bring that in here. And we should see these things start to move. Oh. Well, must have made a typo somewhere. There we go. So we get our rigid body component. Oh, I guess we better do that once to start with. That's probably what happened. Which now there's two lines, so I should just use the collapse to get that out of the way. So initially we didn't have any sort of direction there. So we would have had to wait 4 seconds for things to start moving. Hopefully now they'll move at the beginning. Oh, what did I miss? Change direction, get a new random number, assign direction, and I thought I attached it. You can double check. Well, yeah. Oh, our speed is 0. That's why. Put a number in there to start with. Because we can't really move with a speed of 0. Still not moving though. Oh, this still says the speed of 0. Okay, did I not save that? The speed of 2. And over here. Oh, why did I do that? Okay, I don't know why that didn't carry through. Give that a speed of 2 and the other one speed of 2. Usually if we give it a default value, it will show in the inspector. There we go. Our stuff moves in random directions, but we can already see the problem there on the yellow one. And I think the red one did the same thing here off the view. That was an issue that we did not have to worry about with the nav mesh, the pathfinding objects. There is an edge to our world. So let's see where that is. Way I like to do this is just look from above. That one will work. And manually check things with the transform. So it looks like over here, negative 9.6. 10 will probably work. And over here, 10 will work. So I'm just watching the position there. Down here, yeah, 10 will work there. And 10 will work there. So it looks like going 10, as long as we need to keep our X and Z within 10. Oh, to do that, I just held Alt and moved the mouse around. It looks like the eyeball, you can do panning and Control Alt, I guess that's panning. Control Alt is panning and Alt is rotating. That would work as well. The question popped up in the chat room. Can you just save its original location and make sure it doesn't move too far from that? Which that would work as well. just use the Pythagorean theorem, figure out what the distance you want to stay within that is, which would probably make a lot of sense for NPCs like in a village. And you want if your character player knows which hut in the village a particular NPC should be near, we don't want them wandering too far from that. We do need some sort of restriction. So if it's that, whoops, did I delete anything? Okay, nope, push the wrong button. Or, and I'll put a size restriction here. To keep this easy, I'll just keep it within our the 10 to 10. But what Andrew said would make a lot of sense in the storytelling aspects of games. We don't want our NPCs wandering too far from their original position. So our rigid body component, or well, we could go right to the transform, which we can get from the rigid body as read. We could read it directly, but this is a restriction we're actually checking. So I'm just going to go straight to the transform. So our transform.x is bigger than -10. If it's less than -10, I was going to do the negative of all this, but I'll switch it around. So if we get past -10, less than or equal to -10, so not greater than -10, and transform dot x is greater than or equal to +10, oh, that'd be an or. I was going to negate this, so we have to negate our logic as well. I was going to do not all the and stuff, but not a bunch of and is the same as is a bunch of or from De Morgan's laws. So if it's smaller than -10, which I guess I don't need the parentheses if I'm not going to, so the time's right, or we get down to -10, or we get up to +10 in the x, or y'all know what the next couple things are going to be. The z is less than or equal to -10, or dot z is greater than or equal to +10. And I think that'll work. There is still a chance that we could pick the same direction again, or be like right in a corner and still and not get a good enough direction and continue going. So might need to back that off to 9, but oh, I did it again, didn't I? Transform dot position. I think I did that last week as well, didn't I? I just jumped right to the transform, but the transform is made up of a whole bunch of things itself. So our transform dot position for the x and the y does not pass those bounds. So now hopefully it'll stay on the screen. Say pick a random direction. Oh, something didn't work with the yellow one. Well, that didn't work. It would have clearly come back if he hadn't fallen off the screen there. Well, the yellow one just did that again. So I'm going to watch his numbers. -7, -8, -9. Okay, his Z clearly passed that point where he should have turned around, but he did not. So whoops, cursor wasn't where I thought it was. I think this will fix that problem. It'll put a slight gap in there, and that there will be a frame where we're not moving at all. But if we're right at that edge, moving 3 units every time, we could still pass the edge. Let's see if this fixes that. Obviously not the only way to fix that, if it does. Nope. That yellow guy just took right off there. What did I miss there? If the position is less than -10, greater than 10, less than -10, greater than 10. Let me restrict that. Well, I was expecting this part to go really, really quick, and it's already taken longer than I thought it was going to. So now it's a matter of tracking down why that didn't work. Okay, that just didn't apply to the yellow guy at all.
He just seems like he really wants to take off running no matter what you do. Add some checks in here. See if we can track down what's going wrong there. So there's our well, that check didn't help. I'll leave that one in. Yeah. I believe we have seen this in the homework assignments. You might not have realized this is the same thing. In several of the homework assignments, we've picked up a game object
And then we were able to ask for the tag or the name and things about them. And well, everything that's a game object inherits game. Everything's a game objects are the first level child of mono behavior, and they inherit those tags and names and things from there. So we can refer to ourself as a game object without actually creating that game object data, and just access the name or tag or anything like that. That should tell us whether it's yellow ones or red ones in the line. Oh, I think I see the problem. Anybody see NPC in those debug things anywhere?
No, I just see mob.
So I thought the script was attached.
It is.
Some update didn't go through with it, apparently. Let's try that again. Add the script. There it is. Got the number. There we go. So you can see we get some, well, he still did that. I saw him turn at least once. I still only see mob.
There was an NPC there for a split second. It was really far up in the log, like towards the very beginning.
So there he passed the condition, and then it was like his script was no longer applying. Oh, I know why. Put that down here. So I think I see what the problem is. Does anybody else think they see what happened there in the code? He's going to do it again. And the red guy would eventually do it. And notice that it stopped logging both of them. We weren't going into the condition is why that log wasn't catching the first time. And what's going on in the condition? Does anybody want to take a guess at what that is? See if you see what I think the problem that just occurred is. Why I moved the log out of there.
That condition was unreachable.
Because yeah, if we're already moving at top speed and we choose a new direction, we're already going at top speed, right? So when we do this, when we change direction, we probably need to come to a stop. And I guess it just so happened that it wasn't happening to the to the red guy. I don't know why it wasn't happening to the red guy. Then our character can move around amongst them. But it's been a couple seconds now and nobody's falling off the screen. Our yellow guy kind of got stuck there in the corner, so we could improve some conditions. So what's going on is it keeps picking that same direction, I think. It's constantly changing directions. Can't quite get out of the corner. So there's better refinements. I'll leave it to you all to find some better refinements. I didn't want to spend too long. The basic idea is there. We pick a random direction, move in, set that as our new direction. This was causing problems because we weren't stopping our previous movement, which meant we were still moving at top speed, so we'd never change to the new direction. And this can come out of here now. That was just an echo to check things. But some sort of counter and check to see if we're in the range. That was what was missing from that. The pathfinding, because the pathfinding already knows where the edge of the rounds are. We don't have to go past them. I'll make that a little bit bigger. I'll go to 9. So if any of these things happen, our character will turn around and do some different stuff, but then we might want to do the same thing we saw before. So that's just random movement. And both of our things are going to do random movement for a while, but we might need to do that specific movement like we saw before, but not both of the characters will. So clear that, come back over here. So I'm gonna make another script for our actual opponent, as opposed to the NPC, which can inherit from. So I'll just use object-oriented inheritance to grab all that stuff from character. So we still have all that. It'll call the start method that's in character. The thing we'll want to change will happen over here. So we'll add some variables like a public Boolean, a public Boolean called attacking, or is attacking. That way our code reads nicely when we put that in an if statement. If is attacking, or if not is attacking. We'll start that off at false. And then just like we saw before, we can run an update to see whether or not we should do that. I'm gonna do it here first, and then we'll make a change to see something about inheritance. So along with that stuff we inherit from the character, so at this point, it should be the exact same thing if we switch that script out. So on our mob, we'll get rid of the script, collapse some of this stuff because it's taking up a lot of space. There we go. And attach our opponent script, which inherits from character, so we should still have that same movement and everything else. but we don't seem to have the movement, right? And the problem is that we have update over here as well. So it thinks we're trying to write a new update method. And the new one will take priority. The child update method will take priority over the parent update method. So late update can be a good thing. We can just wait till the end of each frame to make sure that the movement has already happened, and then we'll check to see if we need to be attacking or not. There we go. So we got our movement back. There's different ways to do that, different ways to handle it. We could just copy the whole thing over. We could call the parent create a reference to the parent object so we can call the methods from it and do things differently. Lots of different ways to handle that, but you just have to be careful not to override your update method. That was the point I wanted to express. So that's a really easy one to do and to forget about, and accidentally override your update and then have to spend a while trying to figure out why the stuff you inherit's not working like it should. So our example here isn't super complicated, so I'm just going to move it over to the late update, and then we'll just check if is attacking. And if we're attacking, we need a reference to our player. So I'll make a public game object player, which is going to need to be assigned there on the interface. And I always like to do that first so we don't forget about it later. Oh, done. I save it. Have to hit save first. And now we should have a spot on the interface where we can assign that player object. So that's the thing we might want to attack. And again, there's lots of different ways to do it. I just wanted to kind of cover some of our basic logic. The first thing we need to do is set that if it's true, which is kind of like what we saw before. We can check our distance, distance based off the Pythagorean theorem is math f dot square root of our x values squared. I'm writing it out the long way. So body dot is, we do still have the stuff we inherited, right? We still have that body variable in the child script. So we can refer to that. So body dot transform dot x dot position dot x minus the player dot transform. The Zoom things are all kinds of in my way here. Dot position dot x. Then we need to square that. So times that whole thing. Open some parentheses there. So times that plus I'll paste that in and change that to z's over here. So a messy line, I wanted to do that. I'll turn on word wrap so we can see that whole thing. As y'all are probably well aware, it's that that's another very useful place for variables. It's just cleaning up lines like that. Because we can take that data and put it in a variable called X, and then take the player data and put that in a variable called like PX. And then we have a nice clean thing when we get down here. But the Pythagorean theorem again. So the difference between the X coordinates squared plus the difference between the Z coordinates squared, the square root of that tells us how far away the thing is. Normally a good idea to clean up lines like that and stick it in variables so it makes a lot more sense, but we can access them directly right in there. It just makes it look like a mess. Then we can check that distance for against some criteria. So like if distance is less than, and we can come over here and check how close we need to be the same way. So our character, our player is at 0, 0. Just looking at the X and Z's. And here, we probably want to attack if we get about that close. We want to move to our, if we get really close to our player, we'll move to where the player's at as quickly as we can. So where are we at? So it looks like a Z of about negative 1.5. So I'll say if we're less than, if our total distance is about 1.5 units away, so we're right up on the character, then we'll come in and attack. And is attacking is going to be true. Or not is attacking. It was false, so we'll switch it to true. And if we are attacking, what we want to do is move towards set our direction, or set our transform to move towards the players as quickly as we can. So we can set our direction to the player's position, because that's a 3D vector, right? And then we want to move there as quickly as we can. This time I'll clean it up. So player position is player.transform .position. So we'll grab that and take our position. So we can subtract our position from that to find out how far away it is in each of the X, Y, and Z's. Just remember, if we subtract vectors, we do each component separately. So then we can set a target to be our own position, which we can just get to from saying transform.position, and subtract the player position. Actually, I'll go ahead and write it out the long way. I'll just put it all in there so we can see what data we're using. You all know how to reassign things to variables to make it look cleaner. So we'll take our position and subtract the player's position, which actually needs to be the other way. I always want to do change as new minus old. So our current position is the old one, but we want our position to be the player's position. So we'll find that direction, that and set direction to target. So I guess I could have done the whole thing overall. Does that make sense? What I did there? You're probably used to working with numbers, not with vectors. So that subtraction actually subtracts 3 numbers all at once and gives us a new direction that we want to move in. So when we'll try to move that direction as quickly as possible. Speed equals, we'll start moving twice as quickly. Yeah. We'll move twice as quick as, in order to try and attack the character really quick, and then set timer equal to 1, and then do one more check maybe. So like if timer is equal to then on each pass we'll increment our own counter, and if timer gets up to say 10 frames, we'll stop attacking. Equals not is attacking. So we'll just toggle that back and forth between true and false. So when we get really close to the character, we'll set this variable, run through. In most of your games, it's going to be an animation, and that's what we're going to look at after a break here in just a few seconds. I just wanted to look at the core parts of the logic here because we didn't talk about attacking last time. So realistic, and your final version of your game is attacking. It's just going to trigger the animation, but we'll just move really quickly start moving quicker towards the player, like push up against it, and then after 10 frames, so about 1/6 of a second, we'll stop that is attacking and keep the timer running so our character moves away. So then we'll change direction, and is attacking. We also need our timer to be greater than 1. Whoops. Is attacking. The distance is good, and our timer is greater than 1. 60 a sec. We'll go a whole second at 60 frames per second. So if it's been a while since the last time we attacked, and we're close enough, then we'll attack, which is just grabbing the player's position and moving rapidly towards it over and over again for about 10 frames. And after about 10 frames, we'll turn off our is attacking and then call that change direction method. And this little timer we have is going to keep running, and the next time we attack, it gets set back to 1. Does the logic there make sense? Oh, looks like I missed a semicolon. That's got to be on that long line. Nope. Where did I miss a semicolon at? Line 11. Oh, on this long line, the one that had to turn text wrap on for. End. There we go. So that one looks like a mess. Oh, whoops. In C#, so square root is capital Pascal case. Pretty sure in every single language except C# it's lowercase. Did it not exist? Oh, and timer equals 300, we'll just start at something way bigger than 60. So we know we don't trigger our attack thing immediately. That's how I handle timers. Just build my own. I think I've been typing too much Python lately. I'll just put that. All we did was grab that and put it somewhere else. And it's a vector 3, so it needs to go right into vector 3. Not something that forgot to put the type on. So now our stuff should start moving randomly. And when the red one gets close to our character, should attempt to viciously attack him. Probably could have made that a lot closer. Oh, there we go. It's on the other side of the camera. So notice the error. Said the velocity assignment is infinity. So the difference between them was not there was no distance between them basically, and it got smaller and smaller. So fractional numbers, right? 1/2, 1/8, 1/16, 1/64, and it got into those fractions where it was the smallest possible fractional number we can fit in a floating point. 1 over that is the fractional numbers loop back around to infinity. So we don't need to do that check every time. And probably make this a little bit closer. We'll do that if we're like within 4 of it, or 3 of it. If is attacking, let's set that. Oh, we only need to set that once. We can turn this off here. We only need to check that distance once, because once it's there, it should keep trying to pound into it. And that took about 10 minutes longer than I thought it was going to. Okay, that got weird. We don't need to keep doubling it. I'll comment that line out. Again, we would need the conditions. That already took about 10 minutes longer than I anticipated. So we'll stick with the original speed, but when that gets close to our character, why is it not even doing that now? There we go. Start getting that weird movement for about a second. So that happens. So we need a way to check and see if that's going to happen. So that's why I turned the speed up, because I thought it would let's do this. Speed equals 6, so it's faster. Then we'll change back to whatever the speed originally was. Was it 2? But we need a way to see if that's happening. And our player has these hit points. So we can do that right here. So our player object should have a hit points thing. It might make us put this in a try catch block. So they go down by 5. Since we set our player up as a game object, it might not like that we just call that. No. So I'll do this. So I'll make it an actual player object. That way we definitely have hit points in there. And we did that assignment so it knows what they are. And if we select the player from the hierarchy, we should be able to see those hit points go down when that happens. Oh, forgot an assignment. There we go. Now, when it gets there close by, you can see in the hit point things. Well, he's stuck down in the corner. Our yellow one's just kind of wandering around, not paying a lick of attention to it. But there, when the opponent gets near and does that quick jab over, our hit points drop down a little. So that went about 15 minutes longer than I thought it was going to, but did the logic there make sense? Because all of our homework assignments so far, we just get close enough and it detects the collision. But when we're controlling the movement, more so than just keep start in a direction and keep going, we have a few more things to check. So quick recap. Just using the number of frames that have passed to set a timer. And if we're not too far from the edge, or whenever we get close to the edge, we'll pick a random direction, which is just a new vector 3, some direction. And then we'll stop our current movement and start moving in that direction. Up until we get to speed. So just like we were doing with our controls the other day, only the randomness to it. For all of our characters, everything that moves, and then our opponent, we can add to that some a flag to tell if it's attacking or not, a reference to the player that we want to attack, and then another sub timer to see if for the number of frames, just to keep track of when to stop attacking and stuff. And once again, our Pythagorean theorem tells us how close we are to stuff. So we can just set up a distance range well outside of where colliders would be. And if we get in that distance, we'll start attacking. And in most of your games, attacking is going to be an animation. This is really just a few things moving towards the player. And yeah, most of your games, it's going to trigger an animation and then knock off the player hit points just like that. Then after a couple frames have passed, we'll change direction, kind of stop attacking the player, go back to our original speed, and kind of move on from there. Does that logic make sense to everyone? Any questions about that? That's the core concept of logic of, and obviously in the big situations where you have more time than we have in the classroom, you're going to add a whole lot more selection structures. So just lots and lots and lots of selections. Another thing you might also want to do, this is checking 160 times a second, or a lot of you probably already upped it to the more normal current speed of 140 per second. But if the computer is making those adjustments 100 times a second, 60 times a second, even 60 times a second, we might want to add some probability in there. So like do add just a simple probability. So like do a random dot range of 0 to 100, if that's equal to 7. So there's a 1 in 100 chance that on any particular frame, instead of after 60, because a lot of times that will make it flow a little bit better. But see how it's still kind of just a condition to delay it. It's like there's a 1 in 100 chance it'll happen, which is about the same as once a second. This should behave the same. A lot of times doing that and applying that probability can make your game seem to flow a little bit more naturally. Seems to give your characters more natural movement, because an alternative to delay just make it a very unlikely thing to happen, but it still happens every so often. You can see there, that's still pretty high probability, because very, very quickly we went down 20 frames. So you would want to play around with the probabilities and find the one that seems appropriate for yours. And timer, what was that at? Was it 60? I think that's where it was. Once a second. Adjust probability, which I think I misspelled. Whoops. Oh, so instead of a timer, you can use probabilities to make it seem add a touch more realism in there. All right, that went a few minutes longer than I anticipated it. So probably a good time for a break. Did all that make sense? Anybody have any questions? Does 10 minutes sound good? Any comments on a 10-minute break? Are y'all already on break?
Sounds good.
So my clock says 7:35, so we'll get back to it at 7:45. And sorry, that went a few minutes longer than I'd anticipated, but hopefully that makes sense as adjusting that control over. And obviously you're going to want to do a lot of refining on those selection structures when you have more time than we have in a classroom. But I'll see y'all in a moment.